Let me tell you a story about a robot I bought. Now, this wasn't some futuristic AI that could talk back, make coffee, or write code. It was a simple little robot, basic, honest, and obedient. It could do just a few things. It could move forward, turn left or right, sit down, stand up, grab things, that's it. And honestly, I had a blast the first day. I would give it a command: move forward, then turn right, then sit. It was like playing with a really well-trained pet, except this one only did exactly what I told it to. But here's the thing: every time I wanted it to do something, I had to give every single instruction, step by step. Like move forward, turn right, extend arm, grab, over and over again. And that got tedious, fast. So I had an idea. What if I took that whole sequence of steps, move forward, turn, grab, and gave it a name? Let's say, open the door. Then every time I wanted it to do that, I could just say, open the door. Boom. One command, everything happens. That, my friends, was my first function. I just built a high-level instruction from low-level steps the robot already knew. Later, I built another sequence. Go to the dog, pick up the leash, walk around the garden. I called it walk the dog. Now I could just say open the door, walk the dog, and the robot would execute both routines. Simple, clean, reusable. But here's the fun part. This robot, it's not just a toy. It's a metaphor. It's a stand-in for the CPU, the central processing unit in every computer. Because at its core, that's all a CPU is. A fast, reliable, memoryless little robot. It doesn't understand go viral or write an essay. It understands one thing: instructions. Basic ones: move data, add numbers, compare values, jump to a new location in the instruction list. That's it. No creativity, no memory, no judgment. Just obedience and a lot of speed. So when you write code, whether it's in Python, JavaScript, or C++, you're not talking directly to the CPU. You're writing instructions for a translator, a compiler, or an interpreter that turns your human-friendly commands into robotic CPU-level steps. Think of it like this. When I said walk the dog, my robot broke that into go to the dog, grab the leash, walk forward, avoid the tree, come back. That's exactly what software does when it compiles your code. It transforms your logic into machine instructions, the robot's native tongue. And this is the magic of programming. You, the human, break down a problem. You write out clear steps and you build layers from basic instructions to advanced routines until you have built something powerful, something complex, something useful. From opening doors to running factories to something like ChatGPT, it all starts with this: a little robot, a few basic instructions, and a curious human ready to build something. Let's get started. So, what is programming really? We often think of it as typing weird-looking code on a black screen, or building apps, or automating boring stuff. And yes, it's all of that. But at its core, programming is just giving instructions. It's the art of breaking down a task so clearly, so logically, that even a computer or a robot can understand what to do. You're not just telling the machine what to do. You're telling it exactly how to do it, step by step. Now, here's the key. Computers are not smart. They don't get the idea. They don't fill in gaps. They do exactly what you say. Nothing more, nothing less. So programming is about precision. It's about sequence. What happens first? What happens next? It's about conditions. What happens if something goes wrong or changes? It's about repetition. Doing the same task again and again efficiently. And it's about structure. How you organize those instructions so that the whole system makes sense. Think of it like this. You're writing a recipe, not for a chef, but for a robot that's never cooked before and will follow your instructions literally. If you say mix the batter before you have told it how to get the ingredients, it will fail. If you forget to tell it how long to bake, it might bake forever. If there's a typo, it might stop altogether. That's programming. It's how we take human ideas, vague, flexible, creative, and turn them into precise logic that machines can follow. And every programming language, whether it's Python, C++, JavaScript, or Rust, gives you tools to do 4 fundamental things: store and manage data, make decisions using logic, repeat actions using loops, organize instructions into reusable parts. That's it. That's the heart of it all. And once you understand how to do those 4 things, you can program anything, from a calculator to a game to a robot or even an AI.